Hey guys, welcome back. A few months ago I made a video about fixing this broken GTX 970 over here. After getting rid of the short on one of its power rails by replacing the broken MOSFET, I tried to run it, but that did not work. As I mentioned in this video, it is always recommended to also replace the MOSFET drivers, as they likely get damaged when one of the MOSFETs breaks. At that time, however, I had none of the drivers at hand and therefore ended the video. I then had to wait another few weeks for the MOSFET drivers to arrive, and when they did, I replaced the upper two drivers, so these ones over here. As these upper two power rails are connected to the same PCI Express power connector over here, I thought it is a good idea to replace both. However, this did not solve the problem completely, but more on that later. And my long journey trying to diagnose the issue began. Now, alongside this, I also got sick at the beginning of this year. Was brought to hospital several times by ambulance, stayed there for some time, and although we now have June, I'm still only in the process of getting better, but at any point I can require another ride to hospital. I won't go into detail, just for you guys to know why it took me so long to continue this video. So it's a combination of the additional issue that I ran into, as well as me being sick. Now in this video I'll give you a complete rundown on everything I did, and some insight in my thought process so you can follow along. This video is called part 1.5 for the simple reason that I'll not fix the card today, but actually in part number 2. As you can see, there are quite a few components missing on the PCB, and the reason for that is quite simple. After everything I did, suddenly a short occurred. None of the components were damaged, and I expected one of the components to have some sort of solder bridging underneath, shorting some of the legs. I had to remove every single component one by one, measuring for the short in between. After I removed every single component I worked on, the short was still there. This project was very frustrating at times, and this was one of them. I inspected the whole PCB, searching for a shorted SMD passive, splash of solder, or a piece of conductive material stuck somewhere, but nothing. There was absolutely nothing. So my last resort was then to simply wash down the whole PCB using water and soap and a paintbrush. After I did this and flushed the whole PCB with pure alcohol to get rid of the moisture, the short was finally gone. I still don't know what caused it, but it was gone, and yes, washing down most electronics with water and soap is totally fine, as long as you rinse it long enough to remove every bit of soap and flush the whole PCB several times with pure alcohol. Alcohol bonds to water and makes it evaporize very quickly. Now at this point I thought it might be a good idea to explain how the power delivery on a GPU is constructed, how it works in the most basic way, and what all the components does. This hopefully helps you to diagnose issues with your GPU, but upon reviewing how long this was, I'm going to make a separate video, and I'll put a link on top right over here right now that you can click on if you want to have this explanation. This is not the most detailed explanation on how a buck converter works, but how the the power delivery is constructed. And yes, it's a buck converter, it's a synchronous buck converter, and I explain why and how it's constructed the way it is. Now I can actually start to talk about the whole journey. So when I started the video, there was this idea in my head to use the GPU when I removed the broken MOSFET. Before actually replacing it, to see if the GPU chip itself is still fine. I did not show this in the video as it simply did not work. This is where everything started to go wrong. I should have trusted my prior knowledge, but I didn't. In fact, if you remove a broken MOSFET from your GPU, assuming this is the sole issue, and you eliminated the short, without replacing MOSFET driver, a GPU should have no problem starting a new Windows. More on that later when I actually found about that. So after this did not work, I replaced the MOSFET, tried the GPU, and the FAT blew up again. Now at this point it could have been a broken MOSFET from factory. This can happen. It's very, very rare, but I tried one more time just to see, but as the second one blew up as well, I ended the video as replaced MOSFET drivers had not arrived yet. As soon as they did, I proceeded to replace the upper two instead of only the one that is connected to the broken power rail. And my reasoning behind this is simply based on the fact that they are both connected to the same PCI Express power connector, and the other power rail might have gotten a hit when the first one blew up, and I didn't want to take any chances. After replacing both and making sure there was no short, also replaced the broken MOSFET, obviously. I installed the GPU in my computer, and lo and behold, it started up. Yay! Now at this point you may ask, well, if it starts up, why didn't you make another video? Well, the simple answer is, I don't want to pretend I repaired it if it doesn't actually work. When I say I fixed something, I actually fixed it. Upon starting, the first thing I noticed was a ridiculously loud coil whine. That was my first hint that something wasn't right. As I was now alarmed, I didn't jump right into benchmarking, but started a video. It got slightly worse, but not too bad. I then proceeded to start Ark Survival Evolved, a pretty demanding game for this type of GPU. Beside the even louder coil whine, I noticed a very subtle micro stutter. And this indicated to me that maybe something else might not be right. While doing all of these tests, I used a program called GPU-Z. It can show you all sorts of information, for example, power draw from the PCI Express slot over here, and the both power connectors over here. And there was something very strange happening that made me not trust the program temporarily. You see, it reported this GPU to draw 75 watt from the PCI Express slot, which is totally fine, but also reported a power draw from only one of the two PCI Express power connectors that supposedly draws 150 watt, which can't be. There are multiple things wrong with that. An EVGA GTX 970 ACX2 has a rated power draw of only 145 watt. Real-world tests showed a power draw of up to 156 watt while gaming. This is the combined power draw from both PCI Express slot as well as both PCI power connectors. And this power draw simply cannot be the case, as it has not been overclocked, which I made sure it was not, and the chip itself was not like crazy hot, which it would have been if it actually drew that much power. So I mistrusted every reading of the program at this point. I then consulted an electrical engineer from my university. Although he is not specialized in GPU design or familiar with it, he was able to help me anyway. We developed a plan, or rather a road for me to save the card. First off, coil whine is not a major problem for the operation of the GPU. So his advice was to simply change the switching frequency if possible, and I did, from its set 300 kHz to more like 500 kHz, and this was the first modification. Then the reason the MOSFETs broke with this design is the lack of cooling. There is not even enough airflow to guarantee long-term stability, which is a known issue with this specific design from EVGA. So I modified the cooler. In this area over here, directly above the MOSFETs, removed some overhang fins to have more space. I also cut a small heatsink to size, and using a thermal pad, the MOSFETs now have a direct contact heatsink for better cooling. This is by no means the optimal, neither in size nor the way to get rid of the heat, because we are still lacking airflow, but it makes everything just a tiny bit cooler. And this is more than enough for the testing at this point. The last modification I did was a hardwired voltage mod. You see, graphics cards nowadays have an overall power limit they cannot exceed without modification either in BIOS or the way I did it. By giving the controller IC a slightly lower voltage reading, it will adjust its duty cycle to have a higher voltage on the output. And this is done by modifying the feedback pin. And I was planning to get the voltage up by maybe 50 millivolt to maximum of 100 millivolt. As long as I then don't overclock the graphics card, this will cause the GPU to not consume as much current as at any given load. I decided to do it this way instead of using a program for overclocking to have direct voltage control while it's running. After doing all of these modifications, I again tested the GPU. Coil whine went down, MOSFET cooling worked, but the voltage mod had almost no effect, and that got me thinking, as I couldn't figure out why it still had this microstutter. I mean, it could have been the GPU chip itself being damaged, but my gut feeling just told me I missed something. I then again thought about the coil whine. The previous owner never told me about this much coil whine, nor is it known to be that bad. The mod worked and it went down, but shouldn't be that loud in the first place. If I actually fixed every issue with the power delivery. In my thoughts, I went back to the beginning and traced every step I did and thought about every measurement, every bit of information I collected and what I learned so far. And suddenly I remembered something. I opened up the controller datasheet and oh my god, if I just trusted my knowledge and followed through with my idea in the beginning. The controller has no way of detecting if every component is in place or measure exactly what which power rail does. It simply has no need to. And this is the reason I gave up on my original idea. I thought the controller detected something isn't right, and therefore did not allow me the GPU to run. I remembered that only one of the two PCI Express power connectors were displayed to carry any current. And then things started to come together. Because the program showed way more power than the card should consume, I threw out this other factor and completely ignored it. But if the other two power rails, the lower two, would not run, that explains why we only see power on one of the two power connectors, where there was this loud coil whine, and it might even explain this microstutter. Two power rails are simply not enough under heavy load. The microstutter only happened in-game. And also it's not like GPU-Z is a bad program. You simply can't trust every reading all the time. Although I still have no idea why it showed such a high power draw, everything seems to make sense now. I then decided the best course of action would be to replace the lower two MOSFET drivers as well to see what happens. As I don't need the voltage mod anymore, I decided to reverse it. Oh, and the frequency mod, as it's simply a single SMD resistor. Not much work, but it will definitely tell me if the missing lower two power rails were actually the cause of this loud noise. While doing so, however, a few things went wrong. I ripped off an important trace off of the PCB, which I had to replace with this small wire. First, I tried to remove the solder mask to solder to the leftover trace, but I first hit a neighboring trace, and ultimately I was unable to solder to it anyway. Then I noticed I could simply run it over to this passive over here instead. So I did that, and that's okay, at least I hope. But it's not. I already know it's not okay because the wire sticks up too much from the pad. I have a solution for this, but I won't show it in the next video. This is so complicated, I never did it. It's a way that I read on the internet how to repair missing tracers. I have to try it for myself first, and if I can do it, I'll make another video and show you how it's done. But in part number 2, this is something that I'll skip and do off camera. Oh yeah, and at some point my dad thought it would be a great idea to jump scare me while I was working on the main controller over here. For the voltage mod I had to essentially have a wire from here running to somewhere else and stuff like that, and soldering the wire to the controller I did with the hot air gun. So hot air gun, heating up the controller, sticking the wire in to let it attach, and I then had to use my soldering iron to remove some bridging between the legs of this controller, and while I was doing that he jump scared me. I moved my soldering iron and removed these passive components over here. Now I was able to, well, trace back where which component belongs, also through the help of video, and I set them back in place, but I had to remove them, check them for shorts and make sure there is no short and stuff like that, and short is my primary concern, and I'm still not 100% sure if everything is back where it belongs without any bridging, because measuring in here is quite difficult if you don't know the actual component value. Yeah, I hope I did everything correctly. And that is where we are right now. If you try to fix a GPU and it has the same issue that mine had, I recommend you follow the following steps. First, measure for the shorted MOSFETs the way I did in the first video, which is simply you get your multimeter, get it into continuity mode, grab the power connector and stick your probes in one by one. This short noise is totally fine, but it shouldn't sound like this, which would be a short. And then you simply go into each of these holes trying to find the short. And if there is a short on the power connector, you then have to do again what I did, which is get one of the probes to a ground connection. For example, the shield typically is a ground connection. And then you have to measure. On this specific GPU, the dot on the PCB indicates where we have the source connection of the MOSFET, and it's totally fine if the source connection makes a noise. But what shouldn't make a noise, where there should be no connection, is between this pad that is opposite to the dot, because that is the connection to the MOSFET driver. If there is noise, this means that we definitely have damage on the MOSFET and very likely damage the MOSFET driver. If you then remove the broken MOSFET and there is no short on the GPU anymore, it should be able to start up into Windows. If it does, you simply have to replace the broken MOSFET and its respective MOSFET driver. If it doesn't start up, you can assume to have problems with the other power rails. In this case, as I had with the lower two. If there is no short on the other power rails MOSFETs, a simple MOSFET driver replacement should solve the issue. However, if it doesn't, at this point, I highly recommend to measure your GPU chip resistance to make sure that it's not shorted. If there is no resistance, it is dead. If there is at least, let's say, 200 milliohm, you might be fine. The actual chip resistance differs from generation to generation. This one over here has, for example, I think 1 ohm. But I don't recommend you do this before being at this point, as measuring the resistance of your GPU chip may be harmful. Through all of my research, I was unable to determine if this is actually true, but considering the low resistance of a chip and the typical measurement current used for resistance measurement and voltage, I'd say there is a chance that you can damage the chip. And also considering that this is the most important component of your GPU, I highly recommend not doing it before being at this point, because again, it's just a risk you don't have to necessarily take. Now, if the GPU still has some resistance, the next logical step would be a main controller, main IC replacement, if any other possibility got ruled out. And this is the exact course of action I'll follow next video. Get all the components back in place and see if it works. If not, I'll buy a new controller, but I expect it to work as it did with only 2 of the 4 power rails. At this point, I then replaced every MOSFET and every MOSFET driver, which are potential points of failure, so I'll measure in between every component that gets soldered back in place. Another possible point of failure are all my repairs, like this wire over here and the components I had to get back in place. But I'll double check, and I expect everything to be okay in this regard. So I hope you were able to follow along my thought process and learn something. If you liked the video, please leave a like, comment down below, and other than that, thanks for watching and see you next time. Bye!